Is someone calling the conclusion and still it didn't work?
No, not. Yes, like I'm not like.
Yeah, what's so much? Oh, yeah. To draw your attention to what Module 3. Now, what I'm going to say about Module 3 is that most of the work in Module 3 can be done on your own. If you look at the teaching and the assessment process, we discussed that to a good extent. There's one slide that I will want to get deeper into. That's why I have it here again. But that one slide, maybe two, can wait until we discuss intermittent tests. That way, it will save us time. It's more logical that way. And I think that can wait. That's what I'm trying to do. I mean, 2 weeks from now, we're going to officially start the teacher test. We're going to get started in class. We're going to do some activity in class, and that should be the springboard for everybody to get started with their own. Everybody has a partner, right? Okay. If you do it on your own, that's fine, but you don't need any extra credit. Okay. So I want to jumpstart that 2 weeks from now. So I'm going to kind of transfer the kind of switch. So I'm learning in module 4 to today. And what is in module 3 can easily be covered at home and also in class. So today, my goal is to make sure you get a good sense of what it is to interpret sports or performance. Yeah. Both from internet testing, even from standardized tests. And you don't make sense of, sorry. Make sense of that. And two, I want you to improve the literacy of standardized tests. Some literacy, not much. Some literacy on standardized tests, which apparently is not, there isn't much in the textbook. And if you have the newest version, let me know if there's anything on standardized tests that I think are right. Can you read this? It's so fast, right? Three, some literacy in educational measurement. Mental learning. Assessment is about measuring that. There's a fourth item and a fifth item. Get started. I'm going to have you think of something. Maybe from my belief, from your experience, I want you to think of two things, any two things. Let's say height of people. These are very natural phenomena. Sorry, talking about height. Let's say, yeah, height of people. These are naturally happening phenomena. How tall people are, or how much people have traveled the world, or people's interest in sports. Getting an idea? You can have one on your mind. Please get it. Are you there? You have something in mind? I take my notes. That's fine. That's great. Okay, so you have that. Now, when you have it in your mind, I want you to perceive it pictorially by asking this question. How many of the people I know like this particular, if it is a sport, or travel, or cooking, or tithing, or whatever? How many of these people I know want it minimally? How many want it moderately? And how many want it maximally? Okay. So if there are, let's say you have people in one on the y-axis, you know what y-axis is? Some of you do. On the y-axis. Oh, yeah, 10,000, 20,000, 30,000, 10,000. All millions, basically. And then on the x-axis, you have, if it is sports, let's say, play, maybe, sorry, once a year, because that's the rule. But one time in the year, maybe 2 times in the year, maybe 3 times in the year, maybe, that goes on. Let me bring the two axes. Let's talk about the first one, so on the y-axis, this is the y-axis. You have the numbers going up. Maybe 1 or middle. 1, 2, 3, 4, 5 people. Okay. All these people. Okay, and then the x-axis, which is this one, call it frequency. Yeah, frequency. How many times are they interested in that? Does that make sense? Okay, let me hear what you have in mind. And you're also going to number that somehow. The numbers go up that. If it is one time or each month represents maybe 10 times or let's say one maybe 1 week, 1 day, or 30 days. So the numbers go up that way, and the numbers here go up that way. Does it make sense? You know what you're going to do? Okay. So now that you have it in your mind, I want to make it easy for you. Rather than imagining it or drawing it on some paper that has no grades, I'm going to put them on grades. So you're going to use this grid. You're going to decide where is your, this is the y-axis, that's the x-axis. Oh, well, you can put it this way, yeah. I put it this way, that way you have more space. Actually, that way, but okay, so y-axis and x-axis. Numbers go up that way. Numbers go up that way. These are people, and this is frequency or whatever it is that you're trying to from experience, you're trying to map. And you don't have to start on the edge. You can if you want. You can start the line inside. As long as you have your starting point, put that next to your starting point, and then start putting your numbers that way. You know, questions.
Where did we get the numbers from?
Because you know that people are imagining, oh, as I know in this community, they go to the bar like one day in the year, or 5 days or 10 days in the year. Or these people go to church, let's say, want anything. It's your understanding. It's your understanding of that. Any more questions? I didn't want you to get it because then it would make sense to you. That's why I'm having you choose what to map out, rather than me giving you something to map out. Questions, yeah. No? Yeah, you're making that. But you are using the experience you have with that community. They eat pizza 1 day in a year, 5 days in a year, anything. Does that make sense now? So when you get this, put a mark on your starting point and then start putting the numbers that way. I encourage you to skip to use two blocks like one measure. That way you have space to write. So you can count 2 upward, it's 1, another 2, 2, or whatever number you use. If you use every little one, it's going to be crowded. Does that make sense? Okay, let me get started. Your imagination is at work now. That's it. And give it the back, but pass it that way. Give it the next. Start mapping out.
And do we write up here like what we're mapping, so you know?
Sorry?
Do we write on here what we're mapping out?
Well, you're not giving it to me. It's just you're learning too. Label it anything you want. You can say people eating pizza in Albany Park. So that's where you live. Or people going to bars in Evanston. Or people attending sports games in I don't know. Whatever it is that you want. I encourage you to use 2 squares rather than 1 because 1 will be too crowded. So if you speak a square, if you use 2 as 1 measure, that's in the meantime, I think it's so fun.
Oh, I took the link. Whatever you want.
You are older than I. You are older. You share later. You share later.
Doesn't matter.
No, there's many numbers that you can accommodate. Use two squares in one measure. So that is not very crowded.
I don't know.
Question? What on your own? Because when we share, that's what the time. Let me share on your thing.
Oh, man. What is that?
So the people, the amount of people, what is the frequency?
The number of times they engage in that activity. How people. Exactly.
So then it's a line, right? How far?
No, it's a line. Oh. No,
Line chart, right?
okay. I gave you this to make life easy so that you see how there are no bars here, but this has bars. So if you say, okay, these people, people go to about so many people go to bars 5 times a week. So you're going to connect those lines. You're putting a mark here. Makes sense? Yeah, I'm introducing graphs from kindergarten level.
We don't like, I'm 21.
I know. Does it make sense now?
Can you draw like an example on the board?
Oh.
Oh, so like 3 people go to the bar, 2 times.
the bar.
And then you X.
Okay,
Yeah, I'm gonna do that.
Okay. And then those lines.
Wait.
So if two people go to bars 3 times a week, we're going to 2 and 6, put your marks there. And then it goes all the way.
Okay.
And then you're going to tell us your secret. What did you mark? What behavior did you mark? It's a graph. I'm glad the vocabulary came out. Use two squares as one measure.
Can I get another paper? I didn't know. I don't know if I did
Okay,
this right.
the question is, how many people do what, how many times
I
a
know
year
that,
or
but
a
it's
week
just-
or whatever?
It's just the way I.
Just put those little marks, don't worry about this, put them out for us. Wow.
I did yearly.
Ooh, somebody's advanced.
I know.
I
I
see.
yearly.
Oh, you're just one line.
Okay, no, this was a.
Okay, so, you want another one?
Mm-hmm.
Okay. I really want you to get the gist of it. Once you do, we can move forward. Think about it. And think in a progressive way, whether, starting with a small number, small frequencies, like once, twice, 10 times, or 20 times, or 100 times, however you mark it, that's your choice. Which of them is the instead of going to the bars? We don't need to make the marks at this point, but that's okay.
I went yearly.
Okay,
No.
Who said math? What is math?
No, it's a month.
Math. Somebody said math. What is
Because we're
math? It's that it's nothing to do with this. Definitely something like. Once you have your dots marked from lowest to highest, and if it comes down, think of people, and here's a good one here. How many? Imagine number of people, y-axis, and how many times they go to the gym. That's what you're doing?
I'm doing how many people in my community go to core power yoga?
Oh, nice. So because age goes up, that is the older they get to grow. Map them up to 100. When they turn 100, how many times are they going to the gym? Okay. Put those marks, and once you have those marks done, connect them. Connect the marks and draw a line. No, learning is fun. Don't worry. If you don't do things like that, that's fine. It's an opportunity to learn. You wanna, or it's photo, or can I get? If you have your lines that way, your marks that way, some there, some there, some there. You're going to join them with a line like so. Up and down. But it doesn't have to, depending on whether as they grow older, they go to the gym like every day. So it could go up first. And then let's see your graph. Yes, it is a graph. Woohoo. All right.
Really nice.
All right. Nice. I'll let everybody finish, and then you're going to hold up so everybody can see. And you're going to tell us what it is that you make. Once you draw the line, let me know so we can see everyone's. That is multiple. Like the stocks. Yeah. I should know how much money you have to. Okay, hold up your graph. Hold up so everybody can see, and please say what you mapped, one person at a time. Who's gonna get started?
Me.
Okay, go ahead.
People think of Lego Batman in a week.
So give us some numbers.
Okay, so like 3 people, only once a week. Me, 8 people, 4 times. Well, I got. But anyway.
You flip it.
I'm one here. We're 4 people, so like 9 times a week. Plus me. And then 2 people. 8 times a week.
Okay, that sounds good.
Okay.
Someone else,
So I got how many people access to the library linking one?
Okay.
So I put daily 1,
Can you hold up so people can see.
daily 1, and then I can see
And keep rotating
twice
it.
a week, 5 people. 3 times a week, 2 people. Once a month, 4 people, and twice a month, 6 people.
So where the mark goes down, where the mark is really low, how many people?
3 times, 1 time, daily.
Daily. Okay. So the numbers don't go up that way because daily would be at the highest point, right?
Well, you start with 1 people. It's like,
One time, okay, then it would go up that way.
Yeah.
Do the numbers go up that way? Okay, that's fine. Rachel, hold it up and talk about it.
So I did a graph of how many people go to Overwise ice cream, certain amount of days a week. So some weeks people are going less, like 4 times a week. Some people are going 1 days a week. That's
What is that number on the lowest bar graph?
This one?
Yeah, in the middle one. Yeah,
Is that
4 people, how many times?
7 times?
Okay, so that's the same idea as Gladys, because you have that dropping down. Okay. Someone else from this angle. You want to share yours, please? Hold on. You're going to share it,
So mine was how many people in my community go to Core Power weekly?
right?
So I have 4 people that go twice a week,
Okay,
6 people that go 3 times a week,
okay,
8 people, and 8 people that go 4 to 5 times a week.
okay,
And then for 10 people that go 6 times a week,
okay,
12 people that will go, I'm sorry, 12 people that go 6 times a week.
yeah,
And then we have a drop off. The
mhm,
people that go 7 days a week, there's only 2.
okay, that makes perfect sense, thank you. Yeah, go ahead, hold it up so they can see. Okay,
1,000 people once a week.
yeah,
6,000 people, 8 people twice a week,
yeah,
3,000 each, 3 times a week.
yeah. So what is the drop? That drop is what number?
1,000 each, for 5 times.
Okay, so 5 times a week is what? And what is the top most, the highest point?
7,500 people each. That's 7.
The same 7?
The whole, the whole.
The whole. That's a piece of computing. Okay, anybody else wants to share? Please. Go ahead.
I did how many?
Hold it up.
How many times we'll see movies a year, so once a year, most people 7 one movie per year. So then it starts going down, so around 10 people see 5 movies a year. Then it just and every year we have one person that not see movies, so they watch 25 movies. They're the outlier, a little bit.
Oh, I like that language. Like, the language is beginning to come up. Okay, so that was supposed to bring your random access into your random access memory, something about class, mapping data. So you have it current now, brain there. Now you're ready for this activity. So I'm going to give you this. I want you to pay attention. Try reading it. Just read it first. Just read, and try to make sense of it. That's D. Give me any extra. So look at it and just try to read it. Just look at it, try to make sense of it. Read it, try to make sense of it.
What?
Read it silently, please.
Sorry.
Hello. Take your time to understand it. Using that graph, using that scattergram, that's a graph, a type known as scattergram. Don't worry about the vocabulary. So using that graph, Ask yourself one question quietly and provide the answer to yourself quietly. Ask yourself and answer yourself. How many people, da, 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 and then provide the number. Thanks. Ask yourself and answer that question. Graphs are really, really good because they help condense information. They condense information. Like there's so much information on that one page just because it is mapped out. If you were to write in words, that would be pages and pages. So graphs are really great in that way. So you have the question and you have the answer? Can we start hearing those? Let's get a few examples.
How many people are 25 years of age?
Okay, and the answer is?
26,000.
Is that correct? Okay, we'll find out. Someone else? Thank you for that.
Mine was, the median age is 28. How many are people like that? Median age. 28.
Vocabulary is coming out, median, thank you.
And this is about.
More vocabulary. Okay, can we hear from someone else, please? Chitty chatty, say something. What was your question?
Sure it was.
What was the like highest peak? Like, the top ones, the highest peak, and then from 27. I couldn't even see 27,000.
Okay, settle, because I was interested. In my mind, I was still laughing at my laugh. Go ahead.
I can't answer another question. I can put up with another question.
That's fine, later. Anybody else? I'm jumping.
I think I did the same experience. I said, I picked the highest. So I did 20,000 people. 20.
So the answer, so the question was how many people are 28 and, okay. You wanna say
I said, how many people are 20 years old? That's 19.
all right, so now you know how to read graph quietly on your own and without speaking. And you may want to move away from the person sitting too close to you. And if they move closer, move further. You're going to answer these questions based on that graph.
So we write on it?
Read that graph and answer these questions. You're not talking.
Sorry.
Answer, please. Yeah, you're providing the answer. Just write down the answer. Number one, this answer number two, this answer number three. That's all questions. So let's scroll down so you can see your answer. I'm gonna get some marker to write.
1, 7, 2. 28, 4, about 25. I put 20,500. Yeah, I think that's middle. So. Where?
Don't tell them I took markers from that. Okay, should I scroll down? Yeah, it's 12. Boys back. Boys back. This is America biggest. Both quality and quantity. All right, this is time to be friends. Cross check with two other people. So move about and work with two people. Cross check yours. Turn around, work with two people. Four is too many, but some people cannot separate them. 5 is way too many. Okay, Julia. Right. Look the other way, Julia. All right, 3 people work.
Maybe.
I don't know. Oh, yeah, Rachel, then move so Rachel can be with the. Can get a space to look at you. I know. Try to.
Do you want to be with us?
Yeah, then 9:25. It's time to play.
You know, it would have been easier for each of us. Oh, you said first. Oh, you're with them.
For one, I got 7,000.
7,000. I couldn't see the other ones. I was still on number 3 and then
Oh.
got the. Only got 1, 2, 7 and
What'd you get?
2, I got 2.
I have the same thing. Oh my God.
well,
What'd you get?
I wrote 1,000.
Could you lower the question so we could see the first part?
Oh,
Thank you.
Oh, so I guess it'd be like,
I was getting this one. This can't be
but
one, 2, 3, 4, 5. So I think it's this.
I thought it was, I was thinking it's 1,000. Because
It is one, but I'm saying, isn't this the word number 1,000
Yeah.
starts? Is that what you did? 1,000 starts here? Not
Okay,
here.
finish cross checking.
No,
I didn't have here.
but that would be 0. Because look. 2, 3, 4, 5. Right?
That makes sense. So I guess so.
The way people are 52, it did like 1,500. What'd you guys get for 2? How many people are 52? You're like 1,000, right?
Yeah.
Because your one started here, didn't it?
Yeah, almost. But when I count to 5, I count down.
That's what I did too. Okay. So first 3, I got.
But I didn't do it yet because the
All right, so is that anyone? Within no time?
19,
Same, 6,
10.8,
same, 7,
26,
same, 8,
7.8.
what'd you get for 8? That's what I got.
Oh, yeah. That makes sense.
9, what?
I didn't finish.
10, did you get 0.5?
Well, 500.
Yeah.
Mhm.
Oh,
You finished? Okay. Let's start getting that. Your group 1, you are 2. You're 3, and you're 4. So we're going to go that way by numbers and coming back around. So group 1, what is the answer to number 1?
Oh, excuse me, 7,000.
Is that correct? Yes, they got it right. Group 2,
1,000
read the question.
for number 2.
Yeah, read the question.
yeah, just.
I can't see it.
Oh. Yeah, got it.
It's okay. About how many people are 52 years old?
The answer is,
1,000.
is that correct?
About like 1,100. Is it
More accurately?
1,000 like 100? 1,100, 250. Like this.
Yes, actually that is accurate.
Okay.
1,250.
Oh,
my God. Group 3, you have to really be keen. Group 3, number 3. Is that correct?
27,500.
Yes, 27,500. Group 1, number 4. Oh, I'm sorry. Group 4.
About roughly,
Read the question.
how many people are 36 years old and it's only 20,500?
That is correct. Group 1, number 5.
19. Oh, sorry. How many people are 20? Not 19.
19.
19.
19.
19,000.
Well, yeah.
Set the number right. Okay, again, number 5 again.
19,000.
The question is,
How many people are 20? 19,000 people are 20.
right, number 6, group 2.
10,500.
Great question.
Oh, yes. Number 6.
Yeah,
About how many people are 42 years old?
and then again,
10,500.
that is correct. Number 7, 3.
About how many people are 32 years old? 6,000. Let me look. Okay. Yeah, okay. Like 25,000. Not 500. 200.
900. 500.
And more, like 900 or 800.
Okay. But you want to- You're on there, just look more keen. 150? If you have 5,750, you're right on the top. Number 8 was 4.
So it says, how many people are 44 years old? And it's 8,500. I can't see the one.
8,500, is that correct?
Yeah.
No. Okay. 9,250. What?
Yeah, okay, yeah.
Look, move a little bit up.
8,500. 8,700.
9,300?
Is this number 8?
No, it's 8,000. It's 8,000.
I had 8,500.
It's 44. It's 44. Yeah, 44. I got 8,500. It's because it's in between the lines of 9 and 8. Number 8.
Or 8,700.
Number 8.
Yeah, I got 8,700.
Yeah. Are we wrong?
Is it? Is
No,
this
somebody said no. Gladys, why did you say no?
What's
44. No, this is number,
number 8?
right, number 8. Yeah, number 8. About how many people
Right.
are 44 years old?
8,500.
What you have? Or 8,700? It's not 9. It's under the 9.
It's not 9?
No, it's under it.
not on the line.
It's, you know where the 2 is? It's that one.
Okay, I'm not looking at the graph.
Oh, okay.
All right, we said
What do you have?
9,500, so I guess.
9,000.
8,000.
Okay. 8,500. All right, number 10. Sorry,
Number 9.
number 9. Group 1.
About how many people are 25 years old? And we said 26,000.
26,000 is that correct?
Yeah.
More precise?
I said 25,000.
900?
Huh?
How many people are 16? 12,000? Why are you going so far out? Well, number 9.
My bad.
What is the answer to number 9? That is group 1.
25,750.
25,000 and?
800.
No, a little less. 25,500.
No, I said 900.
Number 10, 2.
Five.
No, I read it, yeah.
Five.
How many people?
About how many people are 55 years old?
How many? What is the answer?
500.
That is correct. Group 3, how many people are 16 years old? 12,000. That is correct. Number 12,
How many people are 70%? 3,000.
look closer.
I got
I did.
That's on the dot.
Okay,
3,000.
2,500. 2,500. Okay. I like the way when you had something wrong, you had to go look back and close it up. So that is good. Now let us go. You just read something which is an approximation of the number. This graph that I gave you is an approximation of the number. The numbers are of the number, right? But this is a good way to begin to understand the sense, the reasoning behind. Numbers go up that way on the y-axis. Numbers go up that way on the x-axis. Now tell me what you notice the shape of it. What do you have to say about the shape of it and the number of people in that category? The shape of this graph in relation to the number of people.
Between 25 and 30.
Okay, that means what? Given this population,
But that was the peak. How many?
peak, okay. Aren't you to I want you to look at the peak here. The bump is in the middle. The bump is in the middle. Now, this is an approximation. It's an approximation of the normal curve. What the normal curve does is map out data, looking at two extremes, the lowest extreme, pay attention, the lowest extreme and the highest extreme. Very few people on the lowest extreme, very few people on the highest extreme. The bound is in the middle. And this was it's a mathematical theorem developed over hundreds of years ago. Nobody has been able to prove it wrong, except where there are skewed distributions where something happens and it's all falling one time. Natural phenomena falls in this time. If you look at heights of people, most people are average height. If you look at weights of people, most people are average weights. If you look at interest in different things, most people are somewhere in the middle. This is the law of average. The law of average. Most people are around the average. Look at this score. Most people are around the average. If you take larger numbers, like thousands and thousands. What does that mean? It means that extreme low and extreme high are rare. The bump is in the middle. Now, this bump in the middle, can someone guess what percentage it is of the whole area? What percentage is that of the whole area? You want to guess? Just guess. This bulge here. You want to guess?
70?
Ooh, that's close. It's actually 68%. Now, this is not the standard normal curve. It's an approximation of the normal curve. So I'm going to give you the standard normal curve so that you can see the actual number. So ignore the. Now let's think about the standard. Okay, I'm going to give you this. Study for a few minutes. Make sense of it? This one, I've already given you this. Study it. Make sense of it. It's from another book. It's not from your book. No, I don't think this is from your book. It's from another book. Study, yeah, just put them there. Study that the standard normal curve. When you hear the standard normal curve, that is what. Why is it important? We'll find out in a few minutes. But I just want you to look at it. Look at the standard scores. This is from our textbook, the chart, but not the textbook that we're using. Our students' performance. On your left are standard scores. Okay. Those are standard scores. You have the standard deviations. You have the standard scores. It's actually the second line, the second row is actually IQ scores. I can see the numbers. You have percentile ranks. You have NCEs. NCEs are normal curve equivalencies. And you have standard. Now, there are many different types of standard scores. And we're not interested in all these details, different types of standard scores. We're interested in what the normal curve does. Now, let me point out that this is helpful in the sense that we can tell when we look at a set of scores, we can tell whether the child is somewhere around the middle among the 68%. Now, the 68% is divided into two. There's 34% on this side and 34% on this. So that makes 68. The rest of it, the little here. For any natural occurring phenomena, this standard normal curve can actually explain it. Unless, there's some things like, economics or specific populations where you have a skewed distribution that will go amongst the rest of us. But the standard normal curve is in there. Now, there are two things to note here. These measures, the marks 1, 2, 3, 4, 5, 6, 7, 8. In fact, there are things about this, some details that don't matter right now, but these lines never meet, they go on forever. They are theoretical. But I'm interested in 3 spaces below this line that comes to the top, and the 3 spaces above the lines that comes to the top. So from here, this is a mirror image of that side. You can see that. Okay? This side is equal to that side. What does it mean when you have schools put on this? It means you can compare them. It means you can compare those schools. Why? Because the spaces are the same. The spaces are the same. They don't change. You have 3 on the lower side. You have 3 on the upper side. Can someone guess what they are called? Each one of these is called what? 2 words. Each one space is called what? It is the standard deviation. Have you heard of that before?
Yes.
So there are 3 standard deviations below what is this tip here? This tip here is the arithmetic average, the mean. This is the average. It is the arithmetic average because even though this is in the middle, it's really not the arithmetic. Let me explain that a little. If you have 5 oranges, she has 3, she has 1, she has 15, she has 20. How do you find out how many oranges per person? How do you find out? Divide them by? Yes. You add all the oranges. Let's say you have 10. She has 15. She has 25. She has 2. She has 0. She has 0. You add all of them and then divide by the number of people. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 people. Whatever total you get when you add them up, divide by the number of people, you get the arithmetic mean. The arithmetic mean, I'm just going to put it so don't forget. So because there are different averages. Take that to be the arithmetic mean is to sum up every single I that stands for the object divided by the number of people. This is arithmetic mean. Where you add and divide by the number of people. That's the arithmetic mean. Now, the arithmetic mean is one important measure of the law of average, the central tendency. That's another central tendency. Central tendency, I just talked about it. It's the behavior of naturally occurring phenomena to cluster in the middle. That is central tendency. Then also variability. We're not interested much in that. So central tendency is the behavior of things to cluster in the middle. The average to have more people. That is central tendency. And that's why you have the bulge here. Because this means it was the highest number on the left of the graph. Okay, now let me finish the central tendency. If you get the mean, this means the average, mean or average. It's also called mean. If you get the mean by summing up every orange, this means sum up. Summing up every orange and divided by the number of people, that gives you the arithmetic mean. There are other measures of average. You know them. Have you heard of mode? I've heard of median. You know the median of the set. right? That divides everyone into two, right? Those are also measures of self-attendance, but we like the arithmetic mean because it is more accurate. It takes everything into consideration and divided by the mean. When you say the median is not so accurate, okay, because it only cuts the distribution into two, cuts into two. If you organize schools from top to higher, from highest to lowest, let's say 20 students, and then you cut a 10, say this is the upper group, is the lower group, that's the median. So whatever school there is may not be represented because really does not include every other school. So that's the median, like the median of the road. There's also the mode. Can you see this? No? Well, that's what we'll talk about. The tendency. You can see this, right? Can you?
Yeah.
Oh, okay, so that is one. Two is median, which cuts into two. And three is mode, which means highest frequency. The one that appeals the most. Oh, what about those? I just wanted to complete it.
What did you abbreviate one for? What was it?
Say that again.
Your abbreviation number one was what?
Average
Average.
or mean. It's also called mean. That is the symbol for it. So these three are the measures of central tendency. On the other end, because that is the clustering in the middle, but there are also measures of dispersion, moving apart from the middle, going that way, going that way. That is the range, just spelled range, means range. And you get the range by taking the highest number, subtract the lowest number. You get the range. Yeah, range. From 1 to the range of the scores is from 3 to 15, I would say. Makes sense, right? Okay. But there are also the standard deviation. Standard deviation, these are the standard deviation. It's a measure of variability. Now, the arithmetic mean of the standard deviation, the arithmetic mean is a measure of central tendency, and the standard deviation is a measure of variability. Those two are critical in interpreting school. Now, I know that may not make a lot of sense right now, but I'm going to move one step up. Imagine, can I erase it? Don't feel bad. You don't have to get everything in the detail, just have to have a good sense of reading information. So don't feel bad if this goes over the head. Slowly you will get it. Let's say you are a parent, if you're not, your child has formed two schools. In social studies, the child has 9. The blue one is sharper. Social study. Social study. The child has 9 points out of an exam. Maybe the teacher administered the exam, or maybe it was standardized with it. Let's say it is the teacher's exam. And in math, that same student has, let's say, 78 points. How do you read that? Look at it and tell me what meaning you get. Don't worry about that yet. We'll connect it later. What meaning do you get from those two scores?
Are you trying to find the average or what do you?
No, no, no.
What is your question?
You just looking at the report. The child has 90 in social studies, and the child has math in 78.
So he's got
What
a
does
C,
it tell you?
and he has an A and a C.
A and a C, okay. Anything else? You need to be reinforcement in math. Okay, let's keep talking. Anything else? Okay. So the assumption here, you're making a lot of stuff. My first question is, let me just think. Out of total.
Oh,
What if it is 90 out of 90?
still an A.
Okay, so that's good. Okay, let me change it. What if this is? Okay, and what if this is? Okay. You get the first idea that a school itself does not give it. You need to learn more about the environment. First of all, out of context. The assumption is out of 100. Okay, let's take it because 100 is so common. Yeah, let's assume it's a percentage, and I know that. It's out of 100. All right, that's out of 100. What does it say now? Same thing we said earlier, right? Is the child better in math and social studies? That's what you're saying. Agree? What if you are told, you find out later that the 90 out of 100 was scored by what if you find out later that the 90 out of 100 was really at the, you look at the normal term that you have. What if you find out that the 90 out of 100 is here? You know the average. For standard deviation of the mean. And that the math out of 100, 78, is here. 2 standard deviations above the mean. What does that mean? Let's see how the class performed. Okay. In this class, the average was, this is not common. The average was 88. Okay. And in this class, the average was 50. What do you think now? Think about it.
He did higher than the average.
Say that again.
He did higher than the average.
In what? In both. It's not beginning to change, right? Why?
Because the average was 50.
Right. Because the average is 50, and this guy is 28, 28 points above it. Okay. What if you realize that the standard deviation here is 2, and the standard deviation here is 10. What does that mean? What it means is that for every value on this line here, every value has, for social studies, every value has 10 points. For math, every value has 2 points. So that is why these scores have different points, because the standard deviation is different. Standard deviation is like the average distance from the mean. Think of it that. Forget about the calculation of the distance. The average distance from the mean. For math, it is 2. For social studies, it is 10. Does that add more? How far away, if you count, oh, I said 2 and not 3. Sorry. This is 2. How far away is this guy from 50 if every measure is 2 points? 50 is in the middle, it's the average. The average is always in the middle. How far away? How many more points does it have? Okay. Now, mapping the standard deviations, if every mark is 2 points, it would be way up compared to social studies, because 1 is 10 points, so it could be just, what's the difference? Just the next mark. In short, this performance is better than that. How does that happen? You're gonna see how it happens. Don't worry. May not make sense of the first time, but what you're going to do now, I'm going to give you this. Right, I'm doing this without mixing with anything else. You see the line that goes through the middle? You're going to draw all of it way down. All the way down. Okay. And then you see these numbers here? You're going to draw lines going, you don't have to start at the top. You're going to draw lines going down from these numbers. Does that make sense? Okay, so you're going to start with the middle, and then you're going to extend the lines going down. And then I'll tell you the next thing to do. Can you do that? Okay. Draw that line and then I'll see the line. Start with the line in the middle, make it a little thicker because that is the average. Talking now, specifically that. Draw a line in the middle, extend the middle line all the way down. Extend the middle line all the way down. If you can use something like a ruler on the line, or something that is straight like the edge of the book. And then the numbers, you see the zero line, extend the 0 line first. All the way down. Nice. And now extend the other numbers down as well. Try to keep the distances parallel. That makes sense. Okay. Now, after that, you're going to draw lines that include these scores on the left. So draw a line just underneath every score that there are 3 things about every score. For example, Z score says mean equals 0, standard deviation equals 1. Just beneath that, draw a line across. The following one says T scores mean equals 50, standard deviation equals 10. Draw a line across. Same thing for the other ones. So you have a grid. Okay, now you're going to work in pairs. 2 brains are better than 1. You're going to work with someone. And what you're doing now, let's do the first one together. We're doing the first one together. These scores are standard scores. I don't know if they're here, let's not turn up. But these scores are standard scores. If you want, I can show you how they're obtained, but that's not important. Just know that they're standard scores. What does it mean, standard scores? Scores that can be explained by that, the standard normal curve. That's what it means, standard. So these scores are standard scores. T scores are standard scores. IQ scores are standard scores. NCE, normal curve equivalencies are standard scores. And percentile ranks are standard. So let's do the first one together. Z score. What is the mean for Z score? Answer. What is the mean for Z score? What is the average for Z score? It's right there. Read it. Zero. Now, take that zero and put it in the middle where your line goes straight down the zero line. Put zero right in the middle of it for Z score. Right. Because this is the line that shows average, right? If the average is zero, it goes on that line. All right. What is the standard deviation for Z scores?
One.
What is the standard deviation for Z scores?
One.
1. Okay. Now we start from 0. Going to the right, it's positive. Left is negative. You want to plug this in? What is the first standard deviation above the mean? That's what the big one. 1. Yes. And what is the first standard deviation below the mean? -1. Now fill in the other. So the mean for these scores is 0. The 0 goes right underneath the line that comes down. One standard deviation above the mean is 1. So the 1 goes on that next line. The -1 goes the other way. Now, if you go up two standard deviations, it's going to be 2. And that side is going to be -2. Same thing, 3 and -3. So fill that in. Write the numbers. Yes. But that's the value of the standard deviation. The standard deviation
Is it here? That is what you're on?
It will make sense when you do the
Okay,
second
this
one.
part, standard deviation.
Now, working the formula,
So
do
the first
the
one
T
is
score. Put in the mean value in the middle, and then fill in the standard deviation.
Can you say that again? Period.
Now do T scores. Put in the mean value in the middle. The average value goes in the middle. And then fill in the other values, depending on where it is on the chart. What is the average for T scores?
It means 50.
Okay, so where does 50 go?
Sit in the middle.
In the middle.
So
And then
we-
fill in the other value. So if the mean is 50, what is the standard deviation?
10.
10. If the standard deviation is 10, what is going to be the measure above 50 if you add 10? 60. What is going to be the next measure? 70. What is going to be the next measure? What about going the other way? Okay, fill it in. Negative. Always to the left it's negative, to the right it's positive. I'm going to give you another.
Wait, how about the standard?
Do the same for IQ scores. Now you want to do.
Where did you put your 10? Did you put your 10? Did you girls put your 10 in here? Did you put a 10?
That will be -4.
Okay, so this would be negative
Negative 40.
40, 30.
Negative 20, 20, negative 10.
Even though it doesn't say negative for the standard deviation.
Yeah, she said put negative on the left side. It shouldn't be negative though. How do you go from negative 40 to 50?
And then if you go to the right, it's 60, 70, 80.
Yeah, it goes up by plus 7, but it goes down. Right?
You got that done?
No,
Help?
please.
Yes.
So if this is, okay, 50 is right here.
Yeah.
And these are my positives.
Yes.
But that's just a 10. That's not a negative 10.
When you go,
Goes down.
you subtract from the middle.
Yeah,
So-
it goes down by 10. You're not supposed to get to 10. You're supposed to get down.
Right, if this is the average, and this is one standard deviation below the average, and one standard deviation is 10, that should be 40.
But it's not negative.
It is negative. It is 40. You're right, it's 40. You just subtract. Oh, thank you, that's important. It
Right?
doesn't have to be negative, just subtract them.
Because the other side is
Oh,
usually
right.
negative.
No, it doesn't have to be negative, just subtract. Just subtract.
That's
But
right.
negative are meant below that. I'm sorry. Thank you.
Well, that's where I got confused, because the other
yeah.
side is always negative.
Right. No, it's always lower than the mean. Okay.
Usually
So
negative.
standard deviation is always lower. Now you realize that. Okay, finish up that. You realize that with stanines, the percentages are not exact because the numbers are actually not on the line. So don't worry about the stanines. In education, we don't use the stanines.
So that's what doesn't have the standard deviation.
The standard deviation are the same, but they are not that standard. They're just forced onto that normal curve. They don't fall on the lines. They fall a little bit below or a little bit above the line. You can estimate, but you cannot put it on the exact place. Okay, you're going to do 2 more things with a partner. I said partner for a reason. 2 brains are better than 1. You're going to plug in social studies and you're going to plug in math. Draw a line underneath and put it.
My what? 15. I just were taking away.
Sorry.
Instead of. I thought these were all these.
Plug in social studies and plug in math. Yeah, not one.
This line.
Plug in social studies and plug in math. See what it looks like.
For this number, it could be the deviation is basically.
Work with
So
the
you're
partner.
gonna go 50 plus
Another
60
brain for
plus
free.
800 plus 50. And then this way you go down. Minus 40. Your mean in the middle, but just. Let's see.
Finished on my phone.
500 and then 120.
Plotting it, right? Maybe if you want to do it. So you're saying add 21, 70, yeah. Then it goes the other way.
Yeah, the negative of minus 21.
We got this right.
And have you plugged in both social studies and math? Okay, actually, I just put the numbers on the top of my head. So which performance is okay, here's the question. In each of those two cases, because this is the same person, the student scored 2 standard deviations above the mean. 2 standard deviations above the mean. What is the score in social studies and what is the score in math? 2 standard deviations above the mean. Remember, it starts at 0 to go up. And you start at 0 to start subtracting. So in both cases, that the student was marked at 2 standard deviations above the mean. So 1 and then the second one. How much would that be for social studies? And then 1 and the second one. How much would that be for math? 96 for math. How did you get that? Okay, did everybody get that? Does that make sense?
In my head, it does,
Yeah.
but like, I can add that up and it makes
Yeah,
sense.
did you add it? Did you add the line at the bottom? Yeah. Okay. Until we make sure everybody's on board. Okay, what if you're told that once you do it, 2 or 3 times, you can do it in your head. You don't have to go the line. What if you're told that in both cases, the student scored right at the mean? Does that make sense? Because there is the 0 in the middle means no deviation, That is why the standard deviation is deviation from the mean. If there is no deviation from the mean, then the score is on the mean. Does that make sense? All right. What if you're told that in both cases, the student scored 2 standard deviations below the mean? 70 and 80. Okay. Make sense, everybody? All right. What if you're told that in math, in social studies, the student scored 1 standard deviation below the mean, and in social studies, the student scored 1 standard deviation above the mean? What are the scores? 70. If social studies is 1 above 5, and then one below for social studies.
75.
Okay. So you see the value. Okay. So you see the position of the normal curve is actually the determinant of how well you have done. And it's not necessarily the exact score. We're going to pick that up. Take a break for 10 minutes and come back. Or something, when the one who will come back in 10 minutes, we're starting everything. question for you. So I almost. Yeah, no, I was doing the. What is that? This is the chunky one. Do you know? What? Yeah.
I don't even know what she's talking about. The next thing that we have to do.
No. It's different.
Just nobody's assignment.
Yeah.
Well, I heard her just say that we have an assignment due with a partner. Gladys, what happened to your blonde?
I kind of put it a little, I didn't like it that much, because I wanted to do white, and she did blonde, remember? So I went today, like, to put it on
A ring?
shoulder, and she said that I have, like, if I wash it like 2 times,
It'll
it'll like come a little lighter.
I like it better dark.
Yeah, it too, I mean, I was like, and it was a huge change, like, more black, more blonde, it's like,
I was not blonde.
yeah.
I'm blonde.
Oh, yeah, I know.
In the spring, when we're black for.
We don't have to be running, like, percent until like after winter.
The rating checklist for preschools by yourself, right?
The one that we have to do on 24. So many questions coming at me, I'm thinking of that, I don't want to be the wrong answer. Yeah, go ahead.
Is it by yourself, the preschool checklist, or is it with partner?
Everything is in partner in that kind. Checklist, rating scale, teacher mid test. Next, when we meet here next, we're going to get started with the teacher mid test.
But the thing due Monday.
No, but we have to have partners to do it. Like that's what I said, I took about it in class and said, if you do it on your own, you're gonna suddenly get extra credit. So yes, the 3 instruments are with the partner. Checklist, rating scale, teacher mid.
Did you say we're doing
Okay.
next week? What are we doing next week?
Sorry?
What are we doing this week?
We're going to, as a group, start the teacher mid test process.
Oh, okay.
I'll get you started. I said
Working
that
on it.
right in class.
Uh-huh.
I said you don't have to worry about that until we start. So,
Okay.
so what happened next week? When we meet
The
in
next meeting, yeah.
No, but the assignments due Mondays.
When you have more than one class, you need to be patient with us, because like it's a lot. That kid's husband, oh my God.
Especially the husband.
Yeah. Luckily, I have to go and deal with my husband after class.
Okay, no class next week, I knew that, and the thing on
There
Monday,
is class only you're working at home.
yeah, that's what I meant. Homework at home,
Class time, there's a lot to do in module 3.
yeah,
I skipped it because it's better done on your own.
module 3 is done at home,
Yeah.
and then,
This is module 4 I'm skipping into,
Yeah.
so that next time we meet here, we only do teacher mid test.
okay, and then the rating scale I can do with my partner, that I can check.
Checklist with partner, rating scale with partner, teacher mid test with partner. We talk about teacher mid test to start together in class when we meet here again.
Yeah, I did it. I got this on my
That's fine.
Yeah, I did, I dropped it already. I got accepted. Yeah, I know, so I'm doing that. Yeah, there, I had to, so I wasn't sure if I wanted to do
So what are we supposed to do after the rating the scale with the partner result? The case study? The which one? Case study? Are you talking about another assignment or like part three? She said that checklist was with the partner. Yeah, there's just one assignment and I have a checklist of rating scale. Like it's part A, part B, part C.
If you read the syllabus, everything is just
Yeah.
so clear. And the scoring guide also tell you exactly what it is that I'll be looking for when you submit your assignment.
Teacher made sense. That's the. That's about like the two. So just in case. So Olivia and I, we didn't know and we sent our separate and we didn't know. Can we just partner up for the
Really, I really don't care. If you do it on your own, I don't care either, because you don't get any extra time. Two people are necessary when it comes to discussing the types of items. You're going to definitely need another brain. If you decide to do it on your
You know
own,
what happened? It's just like I missed the first class and I did not know the.
right, I think so, yeah.
I know,
That's
it's just
what
one.
I'm doing.
Yes, sir. Oh. It's a tablet. Are we gonna get the score for the check level? Like, doing this week or not? Are we getting graded, for the checklist this week? Or not?
Graded? I don't know that either. But I'll grade one that's a picture, of course I'll grade them. I
No,
can't
no, that's what I'm saying.
grade.
Are you gonna give us a score this week or before?
I don't know, as soon as I grade it, we get a score, that's what I'm saying. When you submit your own work always, you don't depend on anybody to submit work just because you work together, no.
Yeah, I know. But we were supposed to be sending the same thing, basically, like we're leaving myself.
That's what I would expect. Some people try to change their own after they are working with a partner, I don't mind that either. Oh, yeah.
And we have 3 people or just 2?
Unless one person is really an extrovert.
Okay.
Oh, that's right, you guys are. We didn't pursue your school. We didn't.
No, but you guys had some. Yeah. Yeah, you guys didn't? No, because we didn't have school. Yeah. So you guys are. Yeah, so our assignments are. We haven't done it. We're not there. Yeah. Oh. Oh, for the videos of the. Yeah. She said that,
I'll show you next week.
It's still frozen. We're supposed to go. Four. She said one of the.
Please read the syllabus about the assignments when you have time, so that you know exactly what required, because that's me off the top of my head, I may not remember, or maybe the wrong thing, just I need to take one side away. But. Yeah. Okay, let's start the learning together. Let's go back to interpreting scores. Now you have the tools to interpret scores. Let's start together so you don't lose it. Okay. So you know what, oh, this is fine, we can take that off, right?
Yes.
Okay. Measurement, you got some aspects of it, you know, the average, arithmetic mean, median, and mode. We're more interested in the arithmetic mean, that's what I want. The other thing that I want you to be aware of is the standard error of measurement. Error of measurement. What does that mean? Well, this is really important. It's very critical. It's very critical in interpreting scores. That's why I did not erase that. But what the standard error of measurement does, it gives you a score value. What is it? It's a statistic. How is it calculated? Forget it. We're not going to go into that. But it is calculated using the standard deviation and the reliability of the test. We're not even there. So what will happen, you will know the standard error of measurement can be abbreviated that way. Let's say equal 4. After calculating using the standard deviation and the reliability of the test, on the report card, you'll see the standard error of measurement. What does that do? It gives you a sense of how much error there was in the test. It gives you a sense of how much error was in the test. Meaning what? Well, when you're doing a test in a room like this, for example, the lighting is too much for you, it's too little for you. Maybe there's some construction work going on in the next room. Maybe the teacher is not loud enough. Maybe the print is not clear enough. Maybe you haven't eaten anything. So there are so many things that can interfere with your actual ability to get things right. Does that make sense? So there are factors that are student related. For example, you call someone on the road when you're driving, you lost your notebook, those are student related. There are exam related factors. Maybe it's not readable. It's too long. The timing is off to the 79 in the morning. There are so many factors that introduce error in the test. What does it mean to introduce error? It means that rather than getting the actual performance of the student, you're getting the performance of the student plus error. Why? Because you're not so good. Why? Because if you did well, the exam was failed. Or because the technology broke down, the items disappeared and then came back. There's so many things that can happen. Now, that is why they calculate the standard error of measurement. The calculation is irrelevant. Nobody's going to ask you to calculate that, but it is calculated by taking the square root of the difference in the reliability divided by the standard deviation. Correctly, just so you know how it comes about. 1 minus the reliability of the text and 5 by n. Take the square root of 1. Don't talk about that. I'll just take the formula. But the most important thing is it gives you a score back. It is calculated using the standard deviation. Oh, you multiply this by the standard deviation. It is calculated using the standard deviation and the difference in the reliability. Forget about that. No concept, whatever. But it gives you the score back. What does it mean? Every score, every raw score is the assigned score. The score that you get when you're given the point. It's a raw score. It hasn't been standardized. So the standard error of measurement will give you the score band. And the score band goes something. The actual score of that student, let's say score adjusted score. Adjusted score equals the score that is assigned, which means the raw score, whatever score that is, plus and minus the percent. If the standard error of measurement is 4, by calculation, all the things that will happen that interfere with your thinking, so with the score that you got was calculated and it came to 4. when you're interpreting score, you have to take that into account. So if the student has 8 points, and the standard deviation, the standard error of measurement is 4. And this is the formula. The score that you're going to use for interpretation is actually that particular score plus n minus the SEM. Now you know the SEM is 4. So what would be the score band? Beginning from what score to what score? Okay, which gives you what? But this score is not written on score. It has errors. To interpret it right, you need to take into consideration the error that went into it. Now you have been told that the error that went into it is 4. And you know to interpret it correctly, you have to add and subtract the error. So a score of 80, what would the score band be? From what to what? All the way to, yes. That is how you interpret. What would the score of 88 given the same standard error method? Okay, that would be 84 to 92. How did you get that? So I think plus and minus the standard error measurement value. What does this mean? This is really critical. This is where we're tying it all together now. We're coming to interpreting sport. When you see sport, a score of 80, say, oh yeah, the score of 80 is so much better than 76, so much better than 78. No. Given the error in the exam, the 80, according to the error, could have been 76, could have been 77, could have been 78, could have been 79, could have been 80. So all those are possible. So somebody who has 84 is not necessarily different from someone who has 80. Does that make sense? If you want to try that, try 84 and draw the score. 84 plus and minus 4 gives you what? 84 plus and minus 4. 2. Right. Does that include the, does it overlap? Yes, it does. If the score bands overlap, then the score does not. Because this is the whole point of going through it today. If the student who got 80, the score of 80 would be 80 plus and minus 4. And that gives you, the 80 would be interpreted as 76 all the way to 84, right? So that could have been any. Now the score of 80, like the same score, or the score of 88, given the same error, would be 88 plus n minus plus and minus 4. That gives you 82 all the way to 84 minus 4. 84 to 92. Now look at these two ranges of score. Look at this range and this range. Do they connect in any way? You see that? That means they overlap. If the school bands overlap, you cannot say the school is. It could have been anything in between. It could have been 77, 78, 79, and this could have been 85, 86, 87, all that. Now, that is how you interpret public schools will select from, actually even from teacher-made tests. Why? Because there is no test that has no error. Every test has error. Student factors, the exam factors, including time, there are scoring factors, even if it is scored by machine, there is always error. How do you take care of error? You can never eliminate error. That does not happen. There is no expert who can run a test without error. What do? You manage the error. How do you manage it? That way. By including it in the interpretation. Questions? Questions or concerns? Okay. I will not introduce any more concept, new concept, I swear. This is good enough for me. Okay, what's enough? What is that? It was enough. So you know how the can we say that's done? Yes. Some literacy? Yes. Some, oh, that is done. Definitely that is done, that is done. Give it a lot. Now, interpretation of scores is really what matters. Because sometimes you have in criteria reference testing, we have high scores. You don't make it to 240, you don't pass. 259, you don't pass. Well, it is a criteria. Okay. But in your own tests, as you administer tests, or as you interpret results of parents, you really want to know what's happening. In short, do you hear people saying, oh, the truth is in the numbers. The numbers speak for themselves. Have you heard that? They don't. Numbers don't speak for themselves. Numbers give you exactly what was encoded in it. Sometimes 1 equals male, 2 equals female. In statistics, you're coding, if you know something about coding data, 1 equals male, 2 equals female, or 1 equals a child, 2 equals an adult. A number. Does it mean that male is twice the female or female is twice the man? No. And we'll talk about that later. But numbers do not speak for themselves. When I gave you the score of 90, you immediately say, oh, the 90 is better than 28. When I said, I don't know how much, realize quickly that it didn't make sense. If it was out of 120, the 90 was low. And if the 78 was out of 78, that was perfect score. So numbers don't speak for themselves. Numbers give you exactly what was encoded in those numbers. Unless you know what was encoded in those numbers, you cannot interpret it. For scores, always interpret the scores in light of the error. In light of the error that they and as a way to start, you know that every test, every exam has error in history. Every score that has been assigned from kindergarten all the way to college, every single score has error in it. Some of the error was your own fault. Some of the error was the fault of the group. Some of the error was the fault of the boyfriend. Some of the error was the fault of the professor. The person wasn't clear. Some of the errors, there are so many errors from different angles. Now, it matters now for the person looking at the score to make meaning out of it, to say, oh, okay, I'm going to see where this score could have been, from what score to what score. So when I'm interpreting the scores, I know that this score could have been so much lower or so much higher. Now, the question comes in, the stakes are high when you're selecting people according to the score. They need to be awarded something, or they need to go into a remedial program, or they need to qualify for some services. Most of the time, that is not utilized, and it is just out of not knowing. But when you think about it, because someone's saying the score is 92, then the child is making 92, the child cannot do this. Right, but you're saying that the exam had no error, right? If it's a standardized exam, it'll always give you the SEM. It'll always tell you the error is this way. So you can include it in the interpretation. Does it make sense now? A score on its own, a raw score on its own does not tell you much. You need to know a lot of things. I mean, how much? Maybe what is the error? I mean, what is the standard deviation? What is the average performance? Out of how much? So you need more information in addition to what you have. I'll let that sink, and the question I thought I would give you, I'll spare that for next week. So let this settle. I mean, not next week, when we meet again. I'm going to be able to recall this information. Write notes so you can recall it. And I'm going to do you a favor. I'll say that right now. I'm going to do you a favor. When we meet next time, I'm going to give you an item similar to an item that will be on the midterm exam. That item will be thought through within a group. You sort it out. You ask questions, so I help you out so you can understand it. So I'll bring it in 2 weeks. Right now, I can feel that you're probably not. You don't have enough energy to go through that. But let it sink, take notes, write down anything you think that would help. And I can give you a few minutes to think through a problem, a real life one, not a hypothetical. Right, it's hypothetical, but typical in education. And you'll try to solve it in a group. That way you'll be ready for the midterm exam. On the final exam, there'll be another question utilizing understanding and interpretation of sports exam. Okay, before we leave this topic, how do you feel about it? How do you feel about this topic?
Oh, I would say.
How big is your brain now? Okay, do you think you can use the information? If you're going to deal with sports, interpreting sports, you better be in the know. Because you may get parents complaining about their children's performance. You have to be able to tell them something. What is the most disturbing or impossible or discouraging something that hits your brain in this section? Let's talk it out. This is therapy.
Well, we can go back to it in the book.
Sorry,
We can go back and read it in the book. Like it's here.
what page?
193.
Oh, that sounds good. Okay.
I'll just forward that.
Okay. What version is that you're looking at? The new version?
6th edition. Yeah.
Oh, good. It's a bit of a sound. Wait, 193?
Yeah, 193. The same.
190?
193.
193. I'm glad it's when that counts. Well, yeah, I look at it.
And then 192 is as house are calculated.
Yeah, now this makes sense, right? All right. The interpretation of sports, the meaning that goes into the sports chart, I don't know what it is. Let's see something else.
Where is it? But they did it alone. I gotta do it alone.
You're on your computers, right?
What do we have to do?
Yeah, don't put some computer. Doing something important.
Are we signing
Well, when we're done with this. Yes, we will, when we're done with this. 6:55. Yeah, we'll go at 6:55.
here or other people?
The ratings.
On your computer, please get into your email. What are you doing something? Somebody's excited about it. That's good. Very, it's rewarding, I'm telling you. I'm sorry for the typo. I got it. You got the email? Yes. I don't know. Who got it already? Me. I'm sorry for the typo, but it doesn't work. I was like, oh. It's like something works like. You type it not. Oh, no. Sign up, sign up, sign up.
We just had to maybe Olivia.
Get the bonus points.
There's a March 27th.
What do you mean?
Oh, no, she's just like, I was just letting them know.
Get the bonus, get the bonus.
Wait, did we?
No, because
Sorry, right.
There's already.
so if there are four, go to another day.
The Gladys, aren't we the three together? Aren't we looking at what's together? The case study. Yeah, this is groups, right?
No, the case study is not.
This is your case study, your case study is not.
You don't worry about it.
When I tell you to work with groups, you don't like it.
That's not true.
When you're supposed to work by yourself, you want to. Now, get on to D12. Look at this coding guide for the presentation of that case study.
Like for this checklist, am I doing it the same way I did my last checklist? The checklist that's due on the 24th.
And somewhere the one.
It's the same way we did our last checklist.
Which checklist is on?
No, for this class.
The infant toddler.
The infant toddler checklist.
So doing that like what tip?
So we have another checklist due.
No, you're talking about ratings. Oh. That's what they said, the different, look at the scoring guys. Really? You can never find it?
It's not, it's me. I'm not good at computers. Not you.
You guys can find math. Why does everyone have math? No, I'm not saying don't. Sorry, guys, for the case study, it's important. Read all the way down. Scoring rubrics for president, scoring rubrics are the end of the rubric for presentation. Go all the way down. You're going to use the Padlet, and you're going to invite 2 people, you're going to get a lot of points for that. There's 3 versions for the first report. That's it. Yeah. You have what? Oh. Well, it's practice.
Not really, but the time is gonna change.
Yeah, it's practice.
No, not today. It's like beginning of March, March 9th, and March 6th. Or March 6th.
And then. I know, that's what we're doing. Look at this one guide. If you look at this one guide, you're ready for it. You're good people. Extra things. I already. Sorry. Oh, here, extra. Thing. Give me the sign-in sheet when everybody has signed up for the judges. All of them have that around. All those? I was returning these. I was returning these and there are people in there. There are no people.
I can walk into everyone.
Can you walk in and just give?
We borrowed
No,
these.
it's all them.
No, it's fine. I thought that we borrowed it.
Just, oh, my.
Well, I'm not. Yeah, it's fine. It's not my phone.
Everybody tried?
And that's all. Joining that more than the actual. Yeah.
Not see you in 2 weeks.
Chicos, she asked me. She's like, oh, no, I can do that. She's like, "Oh, she's like, it's not gonna work." Well, okay. So she just like the part. I guess I'm the rights and the shoes and the. But we're just talking about we're talking about first.
Finish your thing for Maldonado.
Things that we have to do in each class.
Oh, you did? Not that. Oh, you saw that. That's right. You didn't have to do like journal article or whatever.